So here is a quick example to show you how to find the nth term for a quadratic number pattern. Now, since this is my second example, I'm going to go through things a little bit faster and in a little bit less detail. I really do recommend you watch the first video in this series, first example, okay, which I explain things in a bit more detail. So let's get on with it. Firstly, what is a quadratic number pattern? It's just a pattern with a quadratic nth term like this, n squared minus 5. That's just an example. And then the second thing is, how do you check if your pattern is quadratic? We're assuming we don't already know the nth term, so we don't know this yet. How do we check from the number pattern you're given if your pattern is quadratic? Well, you just look at the differences between each term in your pattern. Obviously this pattern is this pattern there. These are the differences between those terms in the pattern, and these are the differences between those differences, i.e. this is the difference between the differences. And if the difference between the differences are common, i.e. the same, that means you have a quadratic number pattern. Now these differences between the differences also tell you how many n squareds there are in the nth term of this pattern. So basically this is always twice the number of n squareds in your nth term for the pattern. So this is 2, that means you've got 1 n squared in your pattern. So how do we start using that to help us get the complete nth term? Well, you draw up a table like this with n over here, and on the right side you've got 1, 2, 3, 4 because we've got 4 terms. So n just means how many, term 1, term 2, term 3, term 4, and as I just said, we've only got 4 terms, so it's only worth going up to 4 over here. Imagine this is blank, n squared minus 5. We haven't reached that bit yet, but on this side just write your number pattern when filling in this table here. So minus 4, minus 1, blah 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 goes in this second row. And then, since we just worked out we've only got 1 n squared in the nth term for this pattern, we write n squared there, because basically this side is the rules for the pattern, this right side are the actual patterns, right? So we know you've got 1 n squared, so you put n squared there, and make the nth term, make the pattern from this nth term, so basically the square numbers, 1, 4, 9, 16, and then take this pattern away from your original pattern, which gives you yet another pattern, a very simple pattern which just goes minus 5, minus 5, minus 5, whatever. Now, what you've done basically is split up your original pattern into 2 parts. This pattern take away this pattern equals that pattern, so the reverse is that this pattern plus this pattern equals the original pattern. So you can do that with the rules or the nth terms for the pattern. So the rule for this pattern is minus 5, the rule for this pattern is n squared. Adding them together gives you the nth term for the original pattern, n squared minus 5, and it's very easy to check that your pattern, or your nth term is correct for this pattern by substituting these n values into here. So for example, let's just pick this one. When n is 2, what do we get? We get 2 squared minus 5, which is minus 1, so that's great, because we wanted to get, when n is 2, we should get minus 1. When n is 3, we should get 4, etc. So you can do that